Hello folks, in this video we'll solve the problem unique paths, which is a medium problem. So we'll be given a grid of m into n size, and from this grid we need to find in how many ways this robot can move from the cell 0 0, that is the top left cell, to the bottom right cell m minus 1 n minus 1. So here in the question it's given the robot can move only either down or right at any point in time, right? So it can if it is at the cell r comma c, that means a row column, then it can either move towards right, that is the same row but the next column, that is rc1, or it can move downwards, that is r plus 1 c, right? So these are the only two possible moves this robot can make, and with this constraint we need to find in how many ways this robot can reach the finish point. Okay, so what we can do is we can solve this using recursion. We can write a recursive function, and using recursion and also using dynamic programming, because in this problem there exists a overlapping subproblem. That is, there can be different paths, right? So when we are computing paths, let's say in one path, it can taking one path, it can reach the finish line. Now when we are calculating another path, there is a possibility that it's after some number of cells, the path remains the same as the previous path. That is, at some point it overlaps, right? So at that particular cell, that is at the point of overlapping, we can say that hey robot, you need not calculate the remaining. Like, we already know that at this particular cell, from this particular cell till the finish point, there are this many number of ways of reaching there. That is, we have already seen for the previous computation. So this robot need not do that again, right? So what we'll be doing is we'll be storing the result of previous computations, and whenever this overlapping happens, we'll check whether during each recursive call we'll check whether this particular cell was already computed. Like, for this particular cell the result was already computed. If yes, we can simply take that result, right? Otherwise we'll continue with the movement of this robot to find the finish point. Okay, and during each recursive call, what we'll be checking is like whether this robot have reached that target point, that is finish point. That is, we'll check whether the current cell this robot is at is m minus 1 n minus 1, that is the bottom right cell, right? The finish point. Okay, so I think we can start coding. So what we can do is, first we can write a variable, right? Number of paths, right? So we can say paths equals, and we can call a function here. Let the function return the final result to it, and we can return this variable to the calling main function. Okay, so here we can write a function get paths, get total paths, and we will be passing the initial row and column. That is, initially in all the cases, like as per the question, the robot will start at 0 0, right? Top left corner. So we can say 0 0, and we can have a function definition for this. This row comma column. We'll come back to this function. So our result will be stored in paths variable, and we can at last return it, right? Return paths. So here the function logic will be this needs to be a recursive function, right? So as per the question, it can move towards right or towards down. So what we can write is we can return this function. It can either move right, so that means the same row but the next column. So row c plus 1. Also, that is one way of moving So by moving that way, we can see in how many ways it can reach the endpoint. And also we need to find by moving down the cell, how many ways are there to reach the finish point, right? So we need to call that path too. So that will be get total paths for the next row but same column, right? C plus 1. Now we need to have a base condition for this, right? For this recursive function. So at each cell we need to check whether we have reached the destination. That is, our destination is the cell m minus 1 n minus 1, right? The last bottom right cell. So we'll check if r equals m minus 1 and c equals n minus 1. That means we have reached the destination. So we can return 1. We can say yes, we have found one path. Okay. So this recursive call will create a lot of recursive calls at each cell, and as soon as it reaches the final destination cell, it returns the result 1 to the calling function, that is to the to its calling function that we have found one path. Okay, so we can return 1 here. And also we need to put some checks, like we don't want to check for rows greater than r and columns greater than c, right? So that is, we need to we don't want that index out of bounds errors and those things. So we need to put a simple check here, that is, if r is it can move till r minus 1, right? So yeah, sorry, it can move on till m minus 1, right? So if r is greater than or equal to m, or c is greater than or equal to n, that means it is out of bounds. So we can return 0. And yeah, so I think that is it. So from this point, that is from the top left point, we'll start the function call, and from there it will check by moving right and down, like in how many ways it can reach to the bottom. Okay, so it will create a lot of recursive calls, and if in case we are finding the destination, we'll return 1. Okay, so at last, after all the calls, the result will be stored in paths variable. So this paths variable will be having the final total number of ways in which this robot can reach the finish cell. Okay, the last bottom right cell. Now let's try running it. There is some error. Okay, so sorry, I wrote the same here. This must be r plus 1, right? R plus 1 c. So let's try running it. Now this function, the code I have written is logically correct, but when we submit it, it may result in time limit exceeded error, because there can be many number of recursive calls, right? So because there is an overlapping sub problem here. Okay, from each cell it can move either towards the right or down. Okay, this will result in moving through the path we have already calculated. Okay, so there will be moving through the same paths multiple times. So what we can do is we can cache the result. Okay, one of the function call might have gone through a path, and at each cell we can store the result. From this cell to the destination, how many ways are there? So if at all another recursive function gets invoked, that function will be going through some cells, and it can check whether this particular cell, it was already calculated, like whether there are any previously calculated result. If yes, then it can take that. Okay, it need not continue further, right? So what we can do is we can cache the result. So for that, we can use a dictionary, cache equal to dictionary, and instead of directly returning the result, we can first store it in dictionary, right? So cache of we need a key to store the result, right? So key it must be unique, right? So we can use row comma column, right? All the cells have unique row and column, right? So we can say cache of r comma c equals this particular function call, and at last we can return the result, cache of r comma c. And at the top of the function, we need to check, like during each call we need to check, right, whether this was already calculated. If yes, we can take the result directly, like we can save a lot of time, right? So here we can say if row comma column in cache, we can directly return the result, cache of row comma column. Okay, so let's try running it. It's working. See you in the next video.